Okay, so we're going to finish chapter 5 by looking at some exam questions, and I just wanted to point out a few different strategies you might think about. So number one, always check the units. They love to switch from centimeters to millimeters or other units partway through a question. Make sure you decide whether it's going around the x-axis or the y-axis and that you know your formulae. Carefully consider what pieces you'll split it into if it's one that requires some splitting up. And last of all, they also like to ask about limitations quite a lot. So just be prepared to have some of the limitations that I mentioned in the previous video ready to go. There are some other really good questions from the exercise as well, which are pretty good to have a go at. So from review exercise 1 in Core Pure 1, there's question 38 and question 39. But I'm going to pick these two from the new spec because there's some weird twists on both of them. So question 8 is pretty easy for part A of the question. So we've got the figure shows a sketch of a curve where it's y equals x to the 2/3. And it says the curve passes through the point A with x coordinate 8. And it says the region R1 is bounded by the curve, the vertical line, the line passing through A and the x-axis. And this region here is R2. So it's not really saying that much interesting. It then says that the solid V1 is rotated by rotating region R1 360 degrees about the x-axis. So this one here is going about the x-axis, and then it says that the second region is going to be rotated about the y-axis. And the first thing it wants us to do is show that the volume of solid V1 is 384 pi over 7. So V1 is the blue bit that we're talking about here. It's rotating about the x-axis. So for part A of the question, we know that the volume is going to be, because it's going about the x-axis, I'm going to have my dx, and it's going to be y squared, and it's going to be between 0 and 8. You can spot here that it's between 0 and 8. We know that y is equal to x to the 2/3. So it's pretty straightforward to see that y squared is going to be x to the 4/3. So what we need to do for part A of the question is just say we're going to integrate pi multiplied by the integral of x to the power of 4 over 3 dx. So I'm going to actually do this integration. I'm going to increase the power to 7 over 3 and then multiply by the reciprocal, which is 3/7 between 0 and 8. And I'm just going to sub in 8 now, because I know that when I sub in the 0 part is going to just be nothing at all. So I'm going to do 8 to the power of 7 over 3, which is 128. Multiply that by 3 over 7. Ooh, it doesn't like this. Oh, it does. And you just get the answer, 384 over 7 pi. I probably should show a little bit of the substitution so they know I haven't just done the entire thing on my calculator. So I would probably say 3/7, 8 to the 7 over 3 minus 3/7, 0 to the 7 over 3. I probably would put that line in if I was doing this in the exam so that I didn't just arrive at that answer too quickly. And this is where it gets a little bit weird, this question. It says the solids V1 and V2 are placed in an empty container. A solid is selected at random and then replaced in the container. This is carried out 10 times. Given that the probability of selecting each type of solid is proportional to its volume, find to 4 decimal places the probability that the solid V2 is selected exactly 8 times. So this is pretty crazy what they're doing here. They're taking something from Core Pure and they are blending it with stats and with probability. But let's not worry too much about what the question's asking for to begin with. Instead, let's say to ourselves, well, we need to pretty much find out what volume 2 is going to be. Otherwise, we're missing out on loads of these 7 marks, okay? Don't know why that jumped back over there. We're missing out on loads of these 7 marks that we've got. So we're actually just going to go ahead and find out what V2 is going to be. I should have said this is V1. Now V2 is being rotated around the y-axis, so it's going to be a dy, and it's going to be x squared. So let's take this bit that we've got. Let's see if we can get what x squared is going to be. Well, if I've got that y equals x to the power of 2 over 3, if I raise this to the power of 3 and this to the power of 3, I will just get x squared equals y cubed. So that's pretty easy. It's actually just going to be integrating pi of y cubed dy. All we need to do now is figure out what the values are going to be. So it's still between 0 and then the other bit that we're trying to find is up here. So if x is equal to 8, y is equal to 8 to the power of 2/3, which you can either put on the calculator or you can just tell that's going to be 4 because the cube root of 8 is 2. So we're integrating between 0 and 4 of y cubed dy. So that's going to be a quarter y to the power of 4 between 0 and 4, which is going to be pi multiplied by a quarter 4 to the power of 4 minus a quarter 0 to the power of 4. Well, that's just going to be 4 to the power of 3, which is just going to be 64 pi. So that's pretty much where lots of the marks are going to come from, but we're now going to try and do actually answering this kind of probability part of the question that's going on here. So it says that their probabilities are proportional to its volume. So we can say really that the probability, well, if it's proportional to the volume, all we need to do is figure out what is the probability of picking either volume 1 or volume 2. So the proportion of getting volume 1 is going to be, in fact, why don't we do the probability of volume 2 instead? Because that's the one that they're asking about. So the probability of picking the shape volume 2 would be the volume of 2 divided by the total volume, which is volume 1 plus volume 2. So volume 2 is going to be 64 pi, and the total volume is going to be the 384 over 7 pi plus 64 pi. That should tell you what proportion of the total volume is volume 2. Now, obviously, I can ignore pi in all of these cases that we've got here, and I'm just going to get this into the calculator. So it is 64 over 384 over 7 plus 64, which is 7 over 13. So the probability of picking volume 2 is 7 over 13, which means the probability of picking volume 1 is just going to be 6 over 13. Think to yourself why that's true. These two probabilities here are going to have to add up to 1. Now, all we really need to do is use our knowledge of binomial probabilities, because this trial is going to be repeated 10 times, so there's a fixed number of trials. The probabilities are going to be fixed because it says that it is being replaced into the container. The trials are all going to be independent of each other, and I can't remember what the last thing is that it needs to be. Oh, and there are two outcomes. You either pick V1 or you pick V2. So we're going to say that V2 is selected exactly 8 times. So the probability that V2 is selected 8 times is just going to be 10 choose 8 multiplied by picking V2 8 times, and then obviously you would have had to pick V1 2 of those times. So 10 choose 8, we're going to do 10 choose 8 multiplied by 7/13 to the power of 8, if I could type that in properly. Multiplied by 6/13 squared. And that's a big number, but it just wanted it to, what did it want it to? 4 decimal places. So to 4 decimal places, 0.0677. If you're not sure about this bit that I'm talking about here, you're going to need to do some recapping of your binomial probabilities from year 1, which is from chapter 6. Okay, let's see if we got this all right. So we have got the correct volume here. Notice how you get 1, 2, 3, 4 marks in part 2 for not even doing the probability part, just for finding the next volume. We got the 7/13. We didn't say that this needed to be binomial. That's kind of implied by what we did there. But you could have done it in this way if you wanted it to. I just did it with words rather than like this, and then 0.0677 to 4 decimal places. So a bit of a weird question, but don't let it put you off. Just find the volume of both of those things, and you've already got 8 out of the 11 marks. So there's only 3 marks for that probability bit at the end. Okay, this next question, it's a new spec one as well. It says a mathematics student is modelling the profile of a glass bottle of water. Profile meaning like the side view. Figure 1 shows a sketch of the central vertical cross-section of the bottle with the measurements taken by the student. So as soon as I see that, I think, that's interesting. The measurements have just been taken by the student. I wonder if they're going to be very accurate. The horizontal cross-section between CF and DE is a circle of diameter 8 centimeters, and the horizontal cross-section between BC and AH is a circle of diameter 2 centimeters. So basically it's just saying this section from here to here, that looks like a cylinder. And also this section at the bottom is also going to be a cylinder. The student thinks that the curve GF could be modelled as a curve with this equation here. So this is the part we're talking about. This bit they think can be modelled with the equation y equals ax squared plus b between x as 1 and 4, where a and b are constants. And all we need to do for the first part is to find the value of a and the value of b according to the model. Well, let's not get too caught up in sort of the difficulties of this. Let's just try and think about in this bit here what the coordinate is. So pretty obviously the coordinate is going to be 4 for the x coordinate, and the y coordinate, so let's just have a look at the diagram, it's just going to be 14. So it's just going to be 4 and 14. And then for this one here, the x coordinate is 1, and I think it's risen up an extra 4, so it's actually going to be the y coordinate is going to be 18 at this bit here. Now you're probably thinking, why is he calculating the coordinates? What are they going to be used for? Well, I'm just going to sub those coordinates into this equation, and it should help me to find out what a and b are. Just see how it goes with me. So we've got y equals ax squared plus b. And what we're going to do is we'll sub in what happens when x equals 1. We know that y is equal to 18. So 18 equals a times 1 squared plus b. When x is equal to 4, y is equal to 14. So 14 is going to be equal to, well, ax squared is going to be 16a plus b. Now, I'm sure you can just tell here, this is going to be simultaneous equations. I always like to use the simultaneous equation solver on my graphics calculator or on the ClassWiz calculator. So you should definitely go to that now. I'm going to go to my simultaneous equation solver and I'm going to do coefficients of a and b are 1, and then you've got that's equal to 18, and then I've got 16a plus b is equal to 14, so that I get these rather unpleasant numbers that a is minus 4/15 and b is 274 over 15. At this stage, you're thinking, uh-oh, I've probably done something wrong because they're such horrible numbers, but you haven't, so you just keep persevering with this. Now it says use the model to find the volume of water that the bottle can contain. So I think what we need to do are these 3 stages. I think we've got cylinder number 1, cylinder number 2, and then we've got a volume of revolution. So we're going to do that volume as 3 separate sections. So the volume is going to be these 3 bits. First of all, I'm going to do cylinder number 1, which I think I've said is the top one. So if the diameter of this is 2, you should be saying to yourself that the radius is half, which is just going to be 1. So the volume of this cylinder is going to be pi r squared h. So that's pi times 1 squared, and I think the height of that bit, the height of that bit is just 10. So it's just going to be 10 pi. Now I'm going to have a look at the second cylinder, which is the big cylinder at the bottom. It's still going to be pi r squared h, and the radius of the bottom part, well, the diameter is 8, so the radius is 4. And the height of that bottom part is 14. So that is going to be 4 times 4 times 14, that's 224 pi. I'm just going to sort of draw my attention to these so that I know to add them on later on. And now I'm going to do the volume of revolution part, my volume of revolution part. And this part is going to be rotated, and I'm looking at this part of the diagram now. This is going to be rotated about the y-axis. So I know that my formula is going to be, with the dy, it's going to be pi x squared dy. And the y-coordinates are between here and here. So let's just add those onto the diagram. The y-coordinates are 14 and 18. So all we need to do really is find out what the x squared bit is. Well, let's look at this beginning part. We have found out that a is minus 4 over 15, and B is 274 over 15. So I'm just going to get rid of those over 15s for a second by multiplying everything by 15. And then I'm going to rearrange it so that 4x squared is equal to 274 minus 15y. And then I'm just going to put the quarter outside the front. I could divide everything by 4, but you'll see why in a second, because what I can now do is I can take this quarter and I can leave it outside the front. So I'm going to put the quarter outside the front, and I'm going to go between 14 and 18 of just this inside bit, which is 274 minus 15y dy. And now I'm going to do the integration. So that's going to go to 274y minus 15 over 2 y squared between 14 and 18. So I'm going to sub in 18 to both of these bits. So it's going to be 274 times 18 minus 15 times 18 squared divided by 2. Minus 15 times 18 squared over 2. I'm going to just write it in the way that I think people would prefer to see this. 15 over 2 times 18 squared, which is 2502. And now I'm going to do the same thing, but instead of it being 18s, I'm just going to replace them with 14s. So I have a 14 here, and I have 14 here, and I'm going to be minusing 2366. So let's do 2502 minus 2366. So that's 136. That's pi over 4 times 136. So let's divide that by 4. Whoops. Let's divide that by 4. And so I get that the volume of that bit is 34 pi. So I'm going to add up for the total volume those 3 bits. So the total volume is going to be 10 pi plus 224 pi plus 34 pi. So that is 10 plus 224 plus 34, which is 268 pi. But because it's asking about the volume of a bottle, I'm actually going to multiply it by pi, which is 841.94. What do they want it to? It just says you find the volume of the water that it contains. So I'm actually just going to give it to the nearest one, which is just going to be 842. So 842 centimeters cubed to the nearest centimeter cubed is what I've done for this particular rounding. So let's see what else we've got. It says state a limitation of the model. So I think one of the limitations I'm going to mention is that the measurements may not be accurate, or I might say that the curve may not actually be a perfect fit for this section of the bottle, because that's the 2 things that you can see that the student has done, that they have done this measurement and they think that it could be modeled in this way. Other things you could say for this is we haven't taken into account the thickness of the glass. This is implying that the glass is really, really, really thin. But I'm going to go for part C with maybe the measurements may not be accurate. So the measurements taken may not be accurate. And now part D of the question wants us to do some kind of interpretation. It says that the label on the bottle states that the bottle holds approximately 750 centimeters cubed of water. Use this information and your answer to part B to evaluate the model, explaining your reasoning. So you do have to do some explanation. You can't just say they are far apart, so it is not a good model. I usually like to work out the percentage error with these things. So for the percentage error, I could do 842 divided by 750, like I did earlier on, and you can see that it is 12% more. So we could say our model suggests the bottle holds 12% more than the label. So this is not a good model. This is not a very good model. Okay, let's have a look at the mark scheme and see that we definitely did get all of this correct. So we've got these weird values for A and B to begin with. No method mark really, sorry, you can just use the calculator for that. We got the 842 centimeters cubed there. Look at all these marks here, just breaking it down nice and slowly. We've got all of these different kinds of things that you could mention. So yeah, you just mention any of these bits we've got here. And then for the last part, it says there are two criteria for this. So you have to do some kind of comparison, and it actually needs to be demonstrated. So you do need to give this comparison part where I said 12%. You could have just done a subtraction to say that they're quite far apart from each other. And you need to have a conclusion to say that this is not a good model, this is a good model, depending on what it's like. Okay, so you just better make sure that that last part, even though it's 1 mark, there should be 2 things. There should be a mathsy calculation bit, and there should be some kind of conclusion bit. Okay, so that is chapter 5 on volumes of revolution. Try those questions from the review exercise that I mentioned at the beginning, and good luck.